Earth's protective blanket. The atmosphere, a dynamic layer of gases surrounding Earth, is crucial for life as it provides oxygen, absorbs ultraviolet solar radiation, moderates temperature, and carries water vapor. Stretching up to 10,000 kilometers above Earth's surface, it's divided into 5 distinct layers, each playing a pivotal role in terrestrial and space weather phenomena. Troposphere, the layer of life. Our journey begins in the troposphere, the lowest layer of the atmosphere, extending about 8 to 15 kilometers above the Earth. This layer is where all weather takes place. It's the air we breathe and the wind we feel. The troposphere contains about 75% of the atmosphere's mass, illustrating its density. The higher you go, the colder it gets, leading us to the fascinating boundary known as the tropopause, where the temperature ceases to decrease with altitude. Stratosphere, the protective shield. As we ascend beyond the tropopause, we enter the stratosphere, stretching up to 50 kilometers above the Earth. This layer is home to the ozone layer, which absorbs and scatters the solar ultraviolet radiation, protecting life on Earth from harmful sun rays. Interestingly, unlike the troposphere, the temperature in the stratosphere increases with altitude due to the absorption of radiation by ozone, a phenomenon that stabilizes the layer and limits weather formations. Mesosphere, the middle frontier. Climbing higher, we reach the Mesosphere, which extends up to about 85 kilometers above Earth. This layer is where most meteoroids burn up upon entry due to the increased density of the atmosphere, creating shooting stars. It is the coldest part of our atmosphere, where temperatures can drop as low as 90 degrees Celsius. Thermosphere, the edge of space. Above the Mesosphere lies the expansive Thermosphere, extending from about 85 kilometers to 600 kilometers above Earth. Here, the air is thin, and temperatures can soar up to 2,500 degrees Celsius due to the absorption of intense solar radiation. This layer is also where the auroras occur, and it's thick enough to reflect radio waves, making long-distance radio communication possible. Exosphere, the final frontier. Finally, we reach the exosphere, the outermost layer of our atmosphere, extending from the top of the thermosphere to about 10,000 kilometers. This layer is where the atmosphere thins out into space, and molecules can escape into orbit. The exosphere is where satellites orbit the Earth, and it marks the transition from our atmospheric protection to the vastness of outer space. Conclusion, a dynamic envelope. From the weather-forming troposphere to the satellite-hosting exosphere, each layer of our atmosphere has a unique story that underscores its importance to life on Earth and our ventures into space. Understanding these layers not only satiates our curiosity, but also enhances our efforts in meteorology, communication, and environmental protection. Like and subscribe